All right, let's do some review, everybody. You can all hear me? Yeah, from what I can tell, you can hear me. So great. So let's talk about chapter 1 a little bit. So some things that are important is you want to know the statistical terms, you want to know key measurement terms, know key research terms, know the place of statistics in science, and understand summation notation. So first of all, you absolutely want to think about your math skills for this course. If you're not, if you don't have basic math skills, it will put you at risk. In Appendix A, the math skills assessment will help you determine if you need a skills review. Also, there's a quick refresher course in your textbook on that. And the final math skills assessment identifies your basic math skills competence. That's important because of it's foundational for this course. So statistics means statistical procedures, the uses of statistics. You want to organize and summarize information. You want to determine exactly what general conclusions are justified based on the specific results that were obtained. And some goals are we want to find meaning, accurate and meaningful interpretation, and standardized evaluation procedures. Statistics are basically when you're referring to your sample. Your population is everybody, and those are parameters. Statistics have to do with the sample or statistical procedures. So next, as we were just talking about, we have our population. So population versus sample is really a critical distinction that will be the basis for understanding many other aspects of applying statistical procedures in this course. So you might want to look at just some of the subtle clues throughout your reading that talk about this. But population as a set of individuals of interest in a particular study that will often vary in size and often be quite large. A sample is a set of individuals selected from a population, usually intended to represent the population in a research study. So the relationship between a population and a sample, the population are all of the individuals of interest. The sample is selected from the population, and the sample, the individuals selected to participate in the research study. And then the results from the sample are generalized to the population. Like you make a broad generalization when you talk about the sample in relationship to the population. So variables and data. A variable is a characteristic. So we'll go back. Yeah, back. A variable is a characteristic or condition that changes or has different values for different individuals. Data is plural. Those are measurements or observations of a variable. You have a data set, a collection of measurements or observations. You have a datum, which is singular. Data is actually plural. A datum is a single measurement or observation, commonly called a score or raw score. So again, parameters and statistics. A parameter is a value, usually a numerical value that describes a population. This is derived from measurements of the individuals in the population. A statistic is a value, usually a numerical value that describes a sample. This is derived from measurements of the individuals in the sample. So as we think about descriptive and inferential statistical methods, as you do your infographics this week, remember descriptive statistics tell us stuff, inferential statistics organize things. So descriptive statistics, you're going to summarize data, organize data, and simplify data. You're going to have some tables, graphs, averages, basically things you can look at. Inferential statistics study samples to make generalizations about the populations from which they were selected. Interpret experimental data. Some common terminology would be sampling error or margin of error or statistically significant. So a sample is never identical to the population. The sampling error, the discrepancy, or the amount of error that exists between a sample statistic and the corresponding population parameter. For example, the margin of error in polls. This poll was taken from a sample of registered voters and has a margin of error plus or minus percentage points. So error is not necessarily something wrong. It has to do with the quantifiable degree of imprecision that is much better than a random guess. So the margin of error is really looking at how accurate the measurement's going to be. So when we talk about, say, the poll, the margin of error plus or minus 4 percentage points, that means give or take 4 percentage points is probably where it's accurate. So the margin of error is like the variability or the difference or the amount of inaccuracy is maybe another way you could think about it. So the role of statistics in research. Well, first of all, we like to compare things. So for example, we want to help organize and simplify collected data. Inferential statistics helps us to interpret the results. So we have the population of college students here, and they read from printed pages or a computer screen, and then we see if their scores are different, and then we show a 4-point average difference between the methods of them studying. However, there's a lot of different ways to interpret the results. We can say there's no difference between the two studying methods, and the difference between the samples is, say, due to chance or sampling error. We can say there is really a difference between the two methods of studying, and the sample data accurately reflect this difference. The goal of inferential statistics is to help researchers decide between the two interpretations. So let's do a learning check. A researcher is interested in the effect of the amount of sleep on a high school student's exam scores. A group of 75 boys agreed to participate in the study. The boys are a statistic, a variable, a parameter, or a sample. What do you think? Think about it. Maybe pause me. Maybe look this up in your textbook. I'll show you the correct answer in a moment. And that is a sample, because it's representative of the population of all the boys in high school. All right, decide if the following statements are true or false. True or false? Most research studies data are from samples. And true or false? When samples differ from the population, there's a systematic difference between the groups. Let's take a moment, think about that. Here is the solution. True, samples used because it's not feasible or possible to measure all the individuals in the population. False, the sampling error due to random influence may produce unsystematic group difference. All right, so science is empirical. Think about the importance of science being empirical. You absolutely want to know that what you're looking at makes sense, not just some random opinion of someone. That's important when you watch the news. That's important when you do research. That's important when you look up things on the internet. The scores that make up the data from a research study are obtained by observing and measuring variables. The process of measurement consists of applying carefully defined measurement procedures for each variable. So next, let's talk about what constructs are. So constructs and the operational definition. So these are two different ways you want to really look at things. So constructs are internal attributes or characteristics that cannot be directly observed. They are useful for describing and explaining behavior. The operational definition identifies a set of operations for measuring an external or observable behavior, and uses the resulting measurements as both a definition and a measurement of a hypothetical construct. So discrete and continuous variables. A discrete variable has separate indivisible categories. No values can exist between two neighboring categories. A continuous variable has an infinite number of possible values between any two observed values, and it's divisible into an infinite number of fractional parts. So for example, if we think about government statistics, that if they say there's a fractional number of children, someone has 1.4 children. Well, you can't have 1.4 children. It's absolutely impossible. So that's the difference between, say, a discrete and a continuous variable. A discrete variable would need to be one or two children. A continuous variable can be divisible into an infinite number of fractional parts. So the government, using statistics about 1.4 children per household, more of a continuous variable versus a discrete variable, because you can't have 0.4 of a child. So continuous measurement, for example, 1.496 to 150.3. Then we also have our real limits, which are in 0.5. It's 0.5 above and below the number. I think we talked about that in the previous lecture. This is just the opportunity to recap a little bit so everything really sticks and is clear for everybody. So let's talk about real limits a little bit more. Real limits are the boundaries of intervals for scores that are represented on a continuous number line. The real limit separating two adjacent scores is located exactly halfway between the two scores. Each score has two real limits. The upper real limit marks the top of the interval. The lower real limit marks the bottom of the interval. So one way to think about this is you might think about a scale in tenths or hundreds, half a score unit above or below the scale value of the measurement unit. So again, half, like the upper is the top of the interval, the real limit is the lower, and it's 0.5 above and below. Some scales of measurement. Measurement assigns individuals or events to categories. The categories can be named such as introvert, extrovert, or employed or unemployed. They can be numerical values such as 68 inches or 175 pounds. The categories used to measure a variable make up a scale of measurement. Relationships between the categories determine the different types of scales. Here's a breakdown. So nominal, so this is called NOR, N-O-I-R, nominal, ordinal, interval, ratio. But what's really important is nominal. It's like an adjective, label and categorize, no quantitative distinctions. Examples: gender, diagnosis, experimental or control, culture, political affiliation. Ordinal, that's categorized as observations. Categories are organized by size or magnitude, ranking class, clothing sizes, small, medium, large, extra large, Olympic medals. Interval, ordered categories, interval between categories of equal size, arbitrary or absent 0 point. Temperature, IQ, golf scores above, below par. And a ratio, ordered categories, equal interval between categories, absolute 0 point, number of correct answers, time to complete a task, gain in height and or weight since the last year. So nominal, adjective, tell me a story. Ordinal, rank, but not necessarily equal distance between points. Interval, rank and equal distance between points, no absolute 0. Ratio, equal distance between points and has an absolute 0. So those are some ways in which you can remember that potentially easier. All right, let's do a learning check. So stay with me here and pause after I get done reading this. A study assesses the optimal size, number of other members for study groups. The variable size of a group is discrete and interval, continuous and ordinal, discrete and ratio, or continuous and interval. Take a moment, pause, think about that, and when you're ready, here we go. That would be discrete and ratio. Next, decide if each of the following statements are true or false. Should actually say are, not is. That would be our subject verb agreement because these statements are plural. Anyways, true, false. Variables cannot be measured directly, cannot be studied. Variables that cannot be measured directly cannot be studied scientifically. And true or false, research measurements are made using specific procedures that define constructs. Take a moment, reflect. What do you think? So false, constructs or interval states can only be observed indirectly, but can be operationally measured. True, operational definitions assure consistent measurement and provide construct definitions. So data structure 1, descriptive research, individual variables. One or more variables measured per individual. Statistics describe the observed variable. May use category or categorical and or numerical variables. Not concerned with relationships between variables. Relationships between variables. If two or more variables are observed and measured in order to determine a relationship, the resulting measurements can be classified into two distinct data structures that are used to determine what type of relationship exists. So if we look at the correlational method, one group of participants measure two variables. The goal is to describe the type and magnitude of the relationship, patterns in the data, reveal relationships, and non-experimental method of study. All right, so this is figure 1.5, data structure, one group of two variables measured for each individual, the correlational method. One of two data structures for studies Evaluating the relationship between variables. Note, there are two separate measurements for each individual. Facebook time and academic performance. The same scores are shown in a table in A and a graph in B. So correlational is just sort of, are the variables moving conversely, like with each other, or are they diverging or inverse away from each other, but they seem to be moving, not necessarily causing one or another, but moving at the same time with each other is your correlational method. So some limits of the correlational method: can demonstrate the existence of a relationship between two variables, does not provide an explanation for the relationship. Most importantly, does not demonstrate a cause and effect relationship between the two variables. Data structure 3, experimental and non-experimental methods, comparing two or more groups of scores. One variable defines the groups. Scores are measured on the second variable. Both experimental and non-experimental studies use this structure. You could also talk about quasi-experimental. When culture, political affiliation, gender, something that's either not manipulated or very difficult to be manipulated, that is going to be a quasi-experimental variable. So one variable we might look at is a type of video game used to define groups, violent or non-violent. A second variable, aggressive behavior, is measured to obtain scores within each group. So this is the data structure for evaluating relationship between variables. If you note, the variables, one variable are used to define the groups, and the second variable is measured to obtain scores in each group between the type of video game and the aggressive behavior. So the experimental method, the goal of an experimental method, and that is to demonstrate a cause and effect relationship between two variables. You also have manipulation. The level of one variable is determined by the experimenter, and then control rules out the influence of other variables, so-called extraneous variables, participant variables, and environmental variables. You have an independent variable, the variable that is manipulated by the researcher. The independent variable, because no other variable in the study influences its value, is manipulated prior to observing the dependent variable. The dependent variable, the one that is observed to assess the effect of treatment. The dependent variable is dependent because its value is thought to depend on the value of the independent variable. You know, a really great way of thinking about this is the variable that depends on the independent variable sort of like leans on it. That's what you want to think about between independent and dependent variable. The independent variable is manipulated and it is not, there's no outcome to it. The outcome variable is the dependent variable. The independent variable is something that like changes with your group of people that that are your participants in your experiment. So some control conditions in an experiment. We have methods of control: random assignment of subjects, matching of subjects, holding the level of some potentially influential variables, which is constant. Control condition: individuals do not receive the experimental treatment. They either receive no treatment or they receive a neutral placebo treatment, which is interesting because there's actually some science showing the placebo effect to be effective. The purpose is to provide a baseline for a comparison with the experimental condition. Individuals do receive the experimental treatment. So Oh, well, clearly I hit the wrong pause button. So sorry about that brief lapse there, guys. So methods of control, random assignment of subjects, matching of subjects, holding the level of some potentially influential variables constant. The control condition, individuals do not receive the experimental treatment. They either receive no treatment or they receive a neutral placebo treatment. Purpose, to provide a baseline for comparison with the experimental condition. The experimental condition, individuals do receive the experimental treatment. So non-equivalent groups, the researcher compares groups of scores. The researcher cannot control who goes into which group. Your pre-test, post-test, individuals are measured at 2 points. The researcher cannot control the influence of the passage of time. Independent variable is quasi-independent. So for example, 2 examples of non-experimental studies. Variable number 1, participation location of the quasi-independent variable, not manipulated, but used to create 2 groups of participants. Variable number 2, verbal test scores, the dependent variable measured in each of the 2 groups. So 2 examples of non-experimental studies that involve comparing 2 groups of scores. In A, the study uses 2 pre-existing groups, suburban and rural, and measures a dependent variable, verbal scores in each group. All right, so let's review that. So we have variable 1, time, the quasi-independent variable, not manipulated, but used to create 2 groups of scores. And then we also have our variable number 2, depression scores, the dependent variable measured at the 2 different times. So 2 examples of non-experimental studies that involve comparing 2 groups of scores. In study A, the study uses 2 pre-existing groups, suburban and rural, and measures the dependent variable, verbal scores in each group. So learning check 1 and 2, researchers observed that students' exam scores were higher the more sleep they had the night before. The study is what? Descriptive, experimental comparison of groups, non-experimental group comparison, or correlational. What do you think? Take a moment, maybe pause me. The answer is correlational. The next one, decide if each of the following statements is true or false. True or false. All research methods have an independent variable. True or false, all research methods can show cause and effect relationships. What do you think? Take a moment, maybe hit pause. So false, correlational methods do not need an independent variable. False, only experiments control the influence of participants and environmental variables. Statistical notation. This is important. You don't want to just glaze over here, okay? So statistics uses operations and notations you already learned. Appendix A has some mathematical review of those, so we'll review that. Statistics also has some specific notation. Scores are referred to as X and Y. N is the number of scores in a population, capital N. Small n is the number of scores in a sample. So large N, everybody. It's a big deal. N, it's a population. It means everybody. N is the smaller group. So small n, think of cliques maybe in high school or college, undergrad. Think about everybody for the large n. Hope that is helpful for statistical notation. So summation notation. Many statistical procedures involve summing or adding a set of scores. The summation sign, sigma, stands for summation. The sigma or summation is always followed by a symbol or equation that defines what is to be summed. Summation is done after operations in parentheses, squaring, and multiplication or division. Summation is done before other addition or subtraction. So the sum of x squared plus 47 instructs you to A, square each score and add 47 to it, then sum those numbers. B, square each score and add up the squared scores, then add 47 to that sum. Add 47 to each score, square the result, and sum those numbers. Or D, add up the scores, square that sum, and add 47 to it. So the correct answer here is square each score, add up the squared scores, then add 47 to that sum. So let's decide if the next ones are true or false. So decide if each of the following equations is true or false. This is true or false, or this is true or false. True, false. Sum of x squared is equivalent to sum of x squared in parentheses, or for the other one, the sum of x times the sum of x is the sum of x to the second power. Well, the first one's false. When the operations are performed in different order, the results are different. True, that is the definition of the sum of x to the second power. So if you're thinking about any of this, equations, concepts, questions, now all the equations are totally posted in the classroom already. Concepts, if you're unsure, the worksheet should help you with that. If you have questions, call, email, text me, 786-879-0179. My email is jkmack@ferrum.edu. Hope to see you all again real soon. Hope you learned something. And I will be posting another lecture very soon.